Hello everyone, welcome back to our channel KSS Gurukul. Today in this video we will discuss the chapter 11 of class 6 math, that is algebra. Before that, if you have not yet subscribed to our channel, please subscribe our channel and press the bell icon to get new video updates. Algebra is a branch of mathematics begun in Egypt during about 1550 BC. During around 300 BC, Indian mathematicians were using first letters of the names of different colors like Ka from Kala or black, Ni from Nila or blue, etc. to denote unknowns, which they called as Bija, Varna, etc. and also forming expressions by them. Examples of few great Indian mathematicians whose contributions to the study of algebra cannot be ignored are Aryabhatta, Brahmagupta, Mahavira and Bhaskara too. The Indian name for algebra is Bijaganit. The word algebra has been derived from the title of the book Algebra wal Mukawala, written by an Arab mathematician Muhammad ibn Musa al-Khwarizmi during about 825 AD. Algebra is a branch of mathematics that uses alphabets known as variables to represent the numbers of unknown value. Let's understand it through an example. Today, the price of apple is 50 rupees per kg. Mamuni bought 3 kg of apple. Now, what will it cost? 50 rupees into 3, that is equal to 150 rupees. Kunman bought 5 kg of apple. What amount he will pay? 50 rupees into 5, that is equal to 250 rupees. Likewise, Bapun bought 7 kg of apple. Thus, he will pay 50 rupees into 7, that is equal to 350 rupees. Note that here the price of apple is constant, but the total price of apple is varying as the quantity per apple is varying. In other words, we can say here price of apple is constant and the quantity of apple is variable. Now, we can use any letter, for example x, to represent the quantity of apple and say the total price of apple to be paid equal to 50x, where x represents any number like 1, 2, 3, 4, 5, 6, 7 and so on. Here the letter x is called as variable. We can use any alphabet like A, B, P, Z, N, etc. as a variable. Remember, a variable is a number which does not have a fixed value. It is changeable. For example, if we take the value of the number 12, it is always 12. Its value will never change. Thus, it is a constant. But a variable can take any value. That means it can represent any number. The idea of variables will help us solving complex problems more easily. Now let's discuss about the uses of variables. Use of variables in common rules. First, using variables in rules from geometry. Let's discuss perimeter of a square. We know perimeter of a square is 4 times the length of a side of it. Now, if we will take a variable p representing the perimeter of a square and a variable l representing the length of its sides, we can say p equal to 4l. Thus, if value of l will change, then the value of p will also change. Here both p and l are variables, but the number 4 is constant. It will not change. Next is perimeter of a rectangle. The perimeter of a rectangle is equal to twice of the sum of its length and breadth. That is 2 into length plus breadth. Now, if we will take a variable p representing the perimeter of a rectangle and L and B representing its length and breadth respectively, we can write p equal to 2 into L plus B, that is equal to 2L plus 2B. Here the value of L and B can change, and according to it the value of P will also change. Here L, P and B all are variables, but the number 2 is constant. It will not change. Likewise, we can construct more general rules in geometry by using the idea of variable. Now come to using variables in rules from arithmetic. Let's discuss commutativity of addition of two numbers. Commutativity means interchanging. Commutativity or commutative property of addition says that changing the order of numbers in an addition does not change the value of their sum. For example, 5 plus 4 equal to 9. 4 plus 5 is also equal to 9. Likewise, 2 plus 3 plus 7 equal to 12. 3 plus 7 plus 2 equal to 12. And 3 plus 2 plus 7 is also equal to 12. Thus, by using the variables, we can make it a general rule. That is, if A and B are variables, then A plus B equal to B plus A. Or if A, B and C are three variables, then A plus B plus C equal to B plus C plus A equal to C plus A plus B. Next is commutativity of multiplication of two numbers. Commutativity or commutative property of multiplication says that changing the order of numbers in a multiplication does not change the value of their product. For example, 7 into 5 equal to 35. 5 into 7 is also equal to 35. Likewise, 5 into 2 into 3 equal to 30. 2 into 3 into 5 equal to 30. And 3 into 5 into 2 is also equal to 30. Now, using the variables, we can make it a general rule that if A and B are two variables, then A into B equal to B into A. Or if A, B and C are three variables, then A into B into C equal to B into C into A equal to C into A into B. Next is distributivity of numbers. The distributive property or distributivity law of multiplication says that multiplying a number by the sum of two or more numbers is the same as the sum of the products of its multiplication with each of these individual numbers. For example, 3 into 7 plus 5 equal to 3 into 12 equal to 36. And we can say that 3 into 7 plus 3 into 5, that is equal to 21 plus 15 equal to 36. Thus, we can say 3 into 7 plus 5 equal to 3 into 7 plus 3 into 5. This is what we call distributivity of numbers. Using variables, we can generalize it like this. For three given variables x, y and z, we can say x into y plus z equal to xy plus xz. Next is expressions with variables. Till now, we knew to express the expressions by using numbers only. For example, 2 into 10 plus 5, 3 by 5 plus 15, 6 plus 5 minus 4, etc. are expressions having numbers only. But now we can also express the expressions by using alphabets, that is variables. Let's discuss some expressions expressed by using variables and know how they are formed. For example, 5x. It is formed by x being multiplied by 5. Likewise, in minus 5x, x is multiplied by minus 5. In x by 15, x is divided by 15. In y plus 20, y is added to 20. In p minus 7, 7 is subtracted from p. In 3x plus 6, first x is multiplied by 3, then 6 is added to the product. In 6x plus 9y, first x is multiplied by 6, then y is multiplied by 9, then the products of both are added. Similarly, when 9 is added to a plus 9 is formed. Likewise, 10 subtracted from b forms b minus 10. L multiplied by 5 forms 5L. Q divided by 3 forms Q by 3. 4 subtracted from minus x forms minus x minus 4. Minus n multiplied by 7 forms minus 7n. Minus z divided by 8 forms minus z by 8. B multiplied by minus 5 forms minus 5b. First x multiplied by minus 3 and then the result added to 8 forms minus 3x plus 8. However, note that we can't get the values of the expressions. Those are formed by using variables. They can only be valued if and only if the values of the variables are given. Let's solve two more problems from your textbook. Question number 1. Form expressions using t and 4. Use not more than one number operation. Every expression must have t in it. The expressions using t and 4 are t plus 4, 4 plus t, t minus 4, 4 minus t, t divided by 4, 4 divided by t, t into 4 and 4 into t. Question number 2. Form expressions using y, 2 and 7. Every expression must have y in it. Use only two number operations. This should be different. The expressions are 2y plus 7, 2y minus 7, 7y plus 2, 7y minus 2, y by 2 plus 7, y by 7 plus 2, y plus 7 by 2, y plus 2 by 7, y plus 7 minus 2, y minus 7 plus 2, y divided by 7 minus 2, etc. Next is using expressions practically. Let's understand practical use of variables through solving some problems from your textbook. Question number 1. Sarita's present age is unknown and is taken y years. Now, what will be her age 5 years from now? He will be y plus 5 years old. What was her age 3 years back? She was y minus 3 years old. What will be the age of her grandfather who is 6 times her age? His age will be y into 6, that is equal to 6y years. What will be the age of her grandmother who is 2 years younger than her grandfather? Her age will be 6y minus 2 years. What will be the age of her father whose age is 5 years more than 3 times Sarita's age? His age will be 3 into y plus 5, that is equal to 3y plus 5 years. Question number 2. Meena, Bina and Leena are climbing the steps to the hilltop. Meena is at step S, Bina is 8 steps ahead and Lina 7 steps behind. Where are Bina and Mina? The total number of steps to the hilltop is 10 less than 4 times what Mina has reached. Express the total number of steps using S. We can get the answer like this. Mina's position is unknown is denoted by variable S. Bina is 8 steps ahead than Mina's position. That is, her position is step S plus 8. Lina is 7 steps behind than Mina's position. Thus, her position is step S minus 7. Total number of steps to the hilltop equal to 10 less than 4 times what Mina has reached, which is equal to 4 into S minus 10. That is equal to 4S minus 10. Next, forming and solving equations. Let's first know what is an equation. An equation is a mathematical statement showing the equality of two expressions by the sign equal to between them, which indicates the value of the left hand side of equal to sign is equal to the value of right hand side of it. Generally, the word equation is used to denote equations that contain variables. For example, 2x plus 3 equal to 7, a by 3 equal to 6, 3m minus 6 equal to 8, like this. But without using variables, equations can also be formed, and they are called as numerical equations. For example, 2 plus 3 equal to 5, 18 by 3 equal to 6, 3 into 3 minus 6 equal to 3, etc. Numerical equations do not have any variable. They are equations with numbers only. However, two expressions with greater than and lesser than sign between them do not form an equation. For example, 7 is greater than 5. 3x plus 5 is less than 2. 5p divided by 3 is greater than 5 are not equations because here the values on both sides are not equal. Solution of an equation. Just now we learned that the value of the left hand side of an equation is equal to the value of right hand side of it. It implies that in an equation containing a variable, the value of the variable must satisfy the equation. Thus, getting the solution of an equation means finding the value of the variable or variables that satisfy the equation. For example, x plus 3 equal to 8. Now, if we take x is equal to 4, x plus 3 will be equal to 4 plus 3 equal to 7. To satisfy this equation, the sum must be 8. And thus, x is equal to 4 does not satisfy this equation. But if we take x is equal to 5, x plus 3 will be equal to 5 plus 3 equal to 8. Thus, x equal to 5 satisfies this equation. And x is equal to 5 is the solution of this equation. Another example. 4l equal to 20. If we will take L is equal to 20, 4L will be equal to 4 into 20, that is 80. Thus, L equal to 20 does not satisfy this equation. And if we will take L equal to 5, 4L will be equal to 4 into 5, that is 20. Thus, L is equal to 5 satisfies this equation, which is the solution. But finding the solution this way is a trial and error method. Practically, it cannot be followed. So, a direct way or a systematic method to solve these equations is needed, which you will learn in your next year's syllabus. This was all about this chapter. Thank you for watching. To get more updates about this subject, please subscribe our channel KSS Gurukul.